Hello, welcome to Chapter 5, Section 1, Graphing Polynomials Functions, Day 3 notes. So this is going to be the last day that we're talking about graphing polynomial functions in this particular context. Now, 2 days ago, right, when we did Day 1, we talked about where to find a relative max or min of a function, right, just by looking at the graph. And we're going to do that again, but we're going to stick on the idea of increasing and decreasing functions. So we want to know where my function is going up and down. And we talked about that a little bit when we talked about quadratic functions, right? It was increasing and then decreasing, or decreasing and then increasing, depending on which way the u was going, right? If it was a frown or if it's a u. So now we're going to talk about it in the context of polynomials, which can be slightly easier to deal with because you can clearly see where it's going up and down, or whatever. So first, let's talk about relative max. Remember, a relative max is the highest point on the graph. Because it's a relative max, there can be multiple of them. So it's not the absolute maximum, right? The highest point is just going to be relative to everything around it. So here, there would be a relative max at A and C, where x equals A and where x equals C, right? That's not the relative maximum value. That's where the relative maximum occurs. If I asked you to find the relative maximum value, you'd have to put the y value. Okay, so pay attention to what it's asking for. A relative minimum would occur at B. So to answer the question, it asks how many points on the graph represent a relative minimum or a relative maximum. So that would be 2 for max and 1 for A, min. Now we need to find where our function is increasing and decreasing. Now, to do that, you read from left to right, you follow the line. So let's follow this line. So from the left, that's way down here, okay? It happens to be low. It doesn't have to be. Left is to the left. And we're going to go up. Okay, that means it's increasing. So it's increasing from negative infinity until we get to that A. Then it's going down. So that's decreasing, right? Because it's going down. So it's decreasing from A to B. Then back up. So that's increasing. All right? So that's from B to C. And then it's going down forever. So it'd be decreasing from C to infinity. Okay, and this is important. So make sure you know how to do this. Practice it. Now we need to put it together, increasing and decreasing, as well as positive or negative. And just a reminder, it's positive when it's above the x-axis, and it's negative when it's below the x-axis. So we need to figure both of these things out. So we're trying to figure out if the function is increasing or decreasing, and if it's positive or negative. So let's look at from point A to point B. From point A to point B, if I draw the line going from left to right, my function is increasing. Also, this is above the x-axis, so it is positive. So it is increasing and positive. Okay, I'm going to abbreviate. Hope that's okay. From point B to point C, well, if I draw the line, it's going down. So because it's going down, this is decreasing. But it's still above the x-axis, so it's still positive. So we've got decreasing and positive. All right, to the left of point A. All right, so remember, I go from left to right. So I'm going to go from left to right. That's going up, so that's increasing. And this time, it is below the x-axis, so it is negative. So it is increasing, but negative. And then to the right of point C, well, that'd be over here. So it's going down, right? Because we're still going from left to right, still from left to right. So it is decreasing, but it's below the end, it's below the x-axis, so it is negative. So decreasing and negative. Abbreviations are fine, just make sure I know what you're saying. Now we have what's called end behavior. End behavior we have dealt with a couple of times now. We just haven't called it end behavior. End behavior is what happens as you go to positive infinity, so all the way to the right, or negative infinity, which is all the way to the left. So let's figure this out. So the end behavior of this graph. Okay. It's determined by the function's degree and the sign of its leading coefficient. Now, if we're just looking at the equation, it's actually very simple. As we go to the right, it's going up forever. So this is how you write it. So as x approaches infinity, y also approaches infinity, right? Because it's going to the right and up forever and ever and ever. Okay? So as it goes to the right, it also goes up. As it goes to the left, okay, so that's this way, left is going down forever and ever and ever. So as x approaches negative infinity, the y values get smaller and smaller and smaller. They go down forever. So it also approaches negative infinity. Okay, so we always want to find out what's happening as x approaches infinity and x approaches negative infinity. And we do this by looking at the y value. That's all graphically. Not as easy to find when you're looking at an equation. So when you look at an equation, we're looking at the leading term. Okay, the leading term is the term with the highest exponent. So in this case, right here. Okay, that is all I care about. I don't care about anything else that's happening in this equation. I only care about the leading term. The leading term here is negative 8x to the 5th power. So negative 8x to the 5th power. That means that it is negative. Okay, so negative and odd. Now when you have an odd function, if it's an odd degree, so use this, please use this, it goes in opposite direction. One goes up and one goes down. So if one goes up and one goes down, and I'm talking about the n values, right, I have these options. One goes up and one goes down, or one goes up and one goes down. Okay? Now normally, for positive, it goes up to the right. For negative, it goes down to the right. So once you realize, well, it's odd, which means that it's going in opposite directions, if it is also negative, then it's going down to the right. Okay, so not this one, because that's going up to the right. So it's doing this, which means as x approaches positive infinity, it's going down to the right. So that means y approaches negative infinity. As x approaches negative infinity, y approaches positive infinity. That's how you know. You can always look at a graph, but this is actually faster. You just have to remember stuff. And there's a chance you will not be given a calculator. So I hope you know your stuff. Even and odd functions. Last thing, an even function. It has two definitions, really, okay? It has the graphical definition and then the algebraic definition. For algebra, what you're going to do is you're going to take negative x and plug it into your equation everywhere you see an x and simplify. Okay, if you get the same equation, then it's even. If you get the opposite equation, it's odd. If you get neither, it's neither. And it can be neither. Graphically, if it's symmetric about the y-axis, so if it's a perfect reflection like you see here, then it is an even function. If it's symmetric about the origin, that's right here, then it is odd. And if it is symmetric about neither of them, then it's neither, right? If it doesn't have that symmetry right there. So let's try this. We'll see what happens. Okay, so first thing, this is algebraically, right? I did not give you much room. So let's plug in negative x. So everywhere I see an x, so that'd be here and here and here, I'm going to plug in negative x instead. So we're going to have 7 negative x cubed plus 3 times negative x to the 4th plus 4 times negative x. All right, now we're going to do negative x cubed. Well, negative times a negative is negative. So I'm going to take that negative and put it up front and do that, okay, because that negative is not going away. Now here, for the 3 times negative x to the 4th, a negative times a negative is positive, and there's 2 of them, right? So if it's an even exponent, then that negative is actually going to go away. So that's plus 3x to the 4th. And then this will be negative 4x, right, because you just pull it. All right, so having said all of that, did we end up with the original equation? No, we did not, right? Because there's this, the first one and the last one are both negative, so it is not even. Did we end up with the exact opposite equation? So what that means is if I were to go ahead and take out a negative, would I get the original equation? Well, let's see. So let's take a negative out of everything. So negative, parentheses, 7x cubed. Okay, that turns negative. That turns positive. Okay, so now on the inside, is that the same as the original equation? No, it is not the same, so it's not odd, which means it is neither. That's how this works. Okay, let's look at it graphically. For a graphic, first it asks, is the degree of the function even or odd? And is the function itself even or odd? So just looking at the equation, the degree, remember, if it's an even exponent, then it goes in the same direction. If it's odd, it goes in the opposite direction. Well, these go in the same direction. So the degree is even. In fact, let's go ahead and say if it's positive or negative. It is positive because it's opening up, right? If it's opening down, it's negative. Now, the function, is the function even? Well, in order for the function to be even, it would have to be a perfect reflection about the y-axis. And if you were to take this paper, fold it in half, you would not get the same thing on both sides of that piece of paper because it's not symmetric. So it is even, but the function is not even. Okay, because it is not symmetric about that line. It is also not odd because then it would have to be symmetric about both. And that's, it's not doing that. Okay, we'll do more examples in class. Have a great day.